Hey, how's it going everyone? My name's Abhinav and today I wanted to talk to you about Ethereum Virtual Machines. It's pretty late at night. Sorry for the low lights and everything, but I hope you have a nice time and you understand what I'm talking about in the first place. With that all that said, let's get started. I want you to remember that EVM is an extremely complicated machine, and even if you don't understand it in the first go, it's fine. Feel free to ask for help. This is EVM and this is you. Whenever you need help, probably reach out to me, probably reach out to some people at EF, or hundreds of other organizations and groups of developers that are out there. A lot of them are generous with their time as long as you're respectful. With that said, let's get started. So let me just check if my mic is working, and hey, it seems to be working. So what is EVM? At a high level, EVM is a deterministic function that outputs a certain value for a certain input. What does that mean? When you give a value to an equation, you don't know if you're going to solve it or not, right? With EVM, there is a certain degree of determinism that it is going to be solved, and the reason for that is something known as gas, right? Gas implementations on EVM are really important, and they help with the determinism so that the EVM does not spiral into a endless cycle of executing a contract, also known as the denial of service attack. That's one of the main reasons why EVM has gas, and we're going to talk a lot more about that. The EVM is much like any other computer, but it specializes in running smart contracts, and EVM is like JVM, but instead of using any other process virtual machines, we use EVM on Ethereum because we need these two things, which are finite determinism and gas implementation. This is a Turing machine, and EVM is called a quasi-Turing machine because a Turing machine is something that can solve anything, and that's because it has an infinite tape right here. All computation models that you see nowadays are kind of a specialized case of universal Turing machine, which was the abstraction of what computers would look like. When you break down human thought process, when you do a 1 plus 2, for example, you don't just think in terms of 1 plus 2 instantly being 3. You have some computation going on there that you have refined to the point where it's that fast, but when you were younger, you probably did 1, that's 3, right? 1 plus 2 is equal to 3. Computers are pretty much the same. It's just that imagine you had infinite fingers, you could pretty much calculate everything, right? But you have 10 fingers, that's a finite tape. You can't have an infinite tape because that would fill up the universe. That's physically impossible. But you can still have determinism of some sorts by implementing rules on when would you stop feeding information to this tape, and that rule for Ethereum is called gas, right? If you run out of gas, it's not going to compute anymore for you, buddy. And that's just such a beautiful concept of introducing deterministic finality onto a machine. It's just called a quasi Turing machine for that reason. It's not truly a Turing machine, but due to the set of rules for input, it kind of will calculate anything for you, and that makes it a Turing machine. Sorry for the if I went down a rabbit hole, sorry for that. Anyway, back to the keynote right here. I'm looking fucking horrible. So you might be noticing a change in the scenery, and that's because the video I was recording last night, right as I was finishing up that slide, my got disconnected, and I didn't figure it out till I was editing the video. So I was speaking into the void for 27 minutes, but don't you worry, I got you covered. I'm here, right? All I'm going to do is I'm going to divide this topic into multiple 5-minute chunks. That's a request I got from a couple of people that I previewed this video to, and I'm going to re-upload a longer version of the video by combining all these chunks as well, so you get one super long video that you can watch while you're having dinner or whatever, and then you're going to get shorter educational bites as well. I'm going to cover a lot of important topics, jump tables. I'm going to go through the Geth code. I'm going to talk about celerity, and I'm going to cover this topic of Turing completeness again, because trust me, we're not done. So once I am done with all of that, you're going to have an excellent resource on EVM. So I would say stick around. press the subscribe button. We're going to discuss a lot more topics outside of EVM as well. We're going to discuss rollups, we're going to discuss Solidity, we're going to discuss security, and I think it's going to be overall a super interesting time. I'm going to get the right signal if you subscribe and give me a like, and you're going to get the right videos. My name's Abhinav, EVM.eth. That's my ENS, and I'm hoping to see you around. Thanks for tuning in, and let's hope this audio got recorded at the very least. See you around.